Welcome back to Tech Simplified channel. In this video, we will learn how to build a secure TCP socket connection in Python using AES encryption. Okay, and in this program, we will implement two scripts. One is a server and second is a client. Okay, so let's first understand that what is AES algorithm. So basically, AES is a symmetric key encryption algorithm, which means the same key is used for both encryption and decryption. And it was established by the NIST in 2001 and replacing the older DES due to its weakness. AES is also known for its speed, security, and efficiency, and it has become the de facto standard for securing sensitive data, whether in files, messages, or over network. So basically, AES operates on fixed size blocks of data, specifically 128 bits or 16 bytes at a time. It supports the three key sizes, 128 bits, 192 bits, and 256 bits. And the encryption process involves multiple rounds of substitution, permutation, mixing, and key addition. It uses a substitution permutation network, that is a SPN structure, making it resistant to known cryptographic attacks. Now let's discuss what are the different applications of AES algorithm. So basically AES used for the secure communication used in the SSL TLS protocols, and that secures the websites. It is also used for end-to-end encrypted messengers like WhatsApp, Signal, and the Telegram. It also used for the Wi-Fi security and uses the protocol WPA2 and WPA3, and mobile, and it also used for the mobile and cloud security that encrypts sensitive data stored on smartphones, cloud storage, and databases. It also used in the banking and the finance applications and for the secure file transfer. So basically, for developing a AES program, we required a one Python library. That name is a PyCryptodome. So for first, you have to install the PyCryptodome library, because Python standard library doesn't have the AES encryption built in. Okay, so let's move for the coding. Okay, so let's start the AES server program by importing the Python socket for TCP communication, AES from PyCryptodome for encryption and decryption, and base 64 to encode binary data into text form. Here we define first a 256-bit key, that is a 32 bytes, and a 16 uh, bytes of IV, and both the client and server must have the same key and the IV for the encryption and decryption process. Okay, now let's design a decrypt message at the server end by passing a one parameter, that is an encrypt message, and it first function takes the encrypted message in base 64, decodes it, create a new cipher in the CBC mode, that is a cipher block chaining mode using the IV, decrypts it, and finally convert it from bytes back to a UTF-8 string. Okay. Now let's create a TCP socket and bind it to a port number 5000, and listen for the TCP incoming connection. Okay. So for that we have to bind to the local host with port number 5000, and after that server is now open to listen the connection. Now print that the server is listening on the port number 5000. Okay. Now here the server wait until a client connects and then print the client address. Okay. And after that we can finally receive the data from the client and now print that the encrypted data received by the server and print the encrypted data. And after that we have to perform the decryption and same as the encrypted message, print the decrypted message. Okay, so we can check that the encryption and decryption is performed smoothly or not. Okay, and finally we can close the connection when done. So we can close the connection and also the server socket. So in this way we can develop a AES server program. Okay. So now let's start the client side code. So just like the server, we have to import the same module, socket for the TCP connection and AES for the encryption and decryption and base 64 encoding for encode the data set. Okay. Now we have to declare the same key and IV for the consistency between client and server. So we have taken the 32 bytes key for the AES 256 and 16 bytes for the IV. Now we first declare one method that is an encrypt message that take a input as a message taken by the user. Okay. This function first check if our message is a multiple of 16 bytes or not. Since we are not using the padding, then it encrypts the message and encode it in a base 64. Okay. Now we have to create a TCP socket and connect with the server. So for that we are using the same process that we done in the server side. We have to first create a TCP socket and after that we have to connect with the local host and port number that we already declared 5000 in the server side. Now we have to take message from the user to enter 16 byte message. Okay, we are not using here any exception if user is not entering the 16 byte message. Okay, now we have to encrypt the message using the encryptor method that we declare in this code and now print that encrypted message sent by the client. Now the client socket sent all the encrypted using the send all encrypted message dot encode. Okay, now we have to finally send the encrypted message and close the connection. Okay, now I am saving this file. Now let's check that this code is working fine or not. So for that we have to open the two different terminals, one for the client and one for the server. Okay, now first run the server in the one terminal. So this is my server file. I run in this console. Okay, you can see that server listening on port number 5000. Now I open the client program and run in another terminal. So it prompts me to enter a message. We have to make sure that the message is must of the 16 bytes. So for that I write, okay. Now I press the enter. You can see the encrypted message sent by the client is this. You can see. Now I check the server console. You can see the encrypted data received by the server is this. And after decryption, the message is this. So that's it. You can now have a working AES encrypted socket communication is in Python. Your message, remember that your message must be a multiple of 16 bytes. If you want to send any length message, you can switch to AES, CFB or OFB mode. So if you found this useful, hit the like button, subscribe and let me know in the comments what encryption method you want me to cover next. Thank you.